So now we will talk about the next property, that is spectral properties. Now, when I talk about the spectral property, see, just imagine this as your medium size ring. And this medium size ring is having two functional groups across the ring. One is the carbonyl group and one is the N-methyl group. So now if you can see these two functional group, these functional groups, of course, they can have interaction with each other because your carbonyl group, if you'll see, the carbonyl have the interaction with the methyl group because this is kind of like electrophile and nucleophile. So now imagine this is your medium size ring, and when you have the medium size ring, remember that the groups across the ring, they are always involved in transannular interaction. So suppose if I say there is no transannular interaction between this carbonyl group and this N-methyl group. So what is the spectral pattern I'm going to expect? Or suppose ये ring में transannular interaction नहीं है. So I'm expected to get the IR frequency stretching, and if I'll take the C13 NMR, I'm supposed to get the peak for the carbonyl. But it has been seen that when I talk about the two groups, definitely they are involved in transannular interaction. And this will bring about some spectral changes. So what are the spectral changes? The first thing you can see here, there is a lowering of the carbonyl frequency. So whatever the stretching you will get it in the IR spectra, you will get the intensity of the peak very smaller. The intensity is smaller, that is indicating the carbonyl is involved in some kind of secondary interaction. And what is that secondary interaction? This is your electrophile and this is your nucleophile. So they can interact with each other, and as they will interact with each other, you must have studied these reactions. When the carbonyl is reacting with the N-methyl groups, there is a nitrogen can donate this lone pair of electron, and then this oxygen will more behave like a OH rather than the carbonyl. So there is a lowering of frequency of the carbonyl. Since, as I told you, this carbonyl is going to behave like more OH rather than double bond O. तो अगर तुम कंपेयर करोगे कीटोन और अल्कोहल को, अल्कोहल has more polarity compared to the ketone. So since alcohol has more polarity, there is unexpected high dipole moment in the reaction. And there is a decrease in reactivity of carbonyl compound. If you allow this compound to give any test related to the carbonyl compound, you will not find that kind of reactions with this compound. The reason behind this is since these two functional groups are present in the medium size ring, and that too across the rings. Since they are present across the rings, they are involved in transannular interaction. There is one more pattern, that one more concept we are going to study later on, that is called a circular dichroism. As you get, for example, I can tell you UV spectroscopy. You have studied the UV spectroscopy, that different functional groups shows you the different UV, they have the specific range of absorptions. And that according to that absorption frequency, you decide which functional group is present. Similarly, we have a concept called a circular dichroism, which is in connection with your UV spectroscopy. So suppose if any functional group is chiral, for example, if I talk about this nitrogen, look at this. On this side, it is attached to CH2M, and this side it is attached to CH2N. M and N, not necessarily they are equal. So suppose I'm saying they're different, and this nitrogen is also attached to this methyl group. So this is a chiral nitrogen. And if it is a chiral nitrogen, it is expected to show certain this certain frequency at the region of 300 nanometers. We are saying that this compound is having a chiral center. And if this is having a chiral center, then in circular dichroism spectra, that we call as CD spectra. So in the CD spectra, it is expected to give a nice peak that we call it as a cotton effect at 300 nanometer. We are going to study this concept. I guess you have that unit in the 4th semester about the circular dichroism. So we are expected to get a nice cotton effect at the 300 nanometer. But when you have the carbonyl frequency. But as we have already said, this carbonyl is involved in the interaction with this nitrogen. So definitely that carbonyl frequency will disappear. So we will not get the appreciable changes or the cotton effect at 300 nanometer. Rather, it says there is appreciable weakening of the cotton effect. So these are the spectral changes than the regular spectra. So if I have a normal spectra for the medium size ring, if there is no transannular interaction, this carbonyl is expected to show the regular spectral properties. But because of the transannular interaction, there are changes in the spectral property of the compound. So this is the one example I have presented. Look at the second example here. Look at the first, that is the middle compound. Again, I have shown you the same compound. There is a carbonyl group, there is a methyl group. This is M and this is N. Now, there are two reactions possible in this case if you carry out the reaction in acidic medium. So what happens in acidic medium? In some cases, it may happen that it forms this kind of hydrogen bonding, that is the cottonization will take place at the nitrogen, and you will get the salt formation, that is ammonium salt formation, that's compound A type. But if there is a transannular interaction, rather than forming this kind of ammonium salt, it will tend to form this kind of compound in the acidic medium. Two reactions possible. Again, I'm repeating. If I will allow this compound to react in the acidic medium, the first thing that can immediately happen is the nitrogen will undergo the cottonization and it will form the ammonium salt here. But since this is a medium size ring and there is an interaction across the groups, therefore, in acidic medium, it will form this kind of compound. Now, if you see this kind of compound, we call this as bicyclo compounds. This side, there is one ring. This side, there is another ring. And this is the intermediate or the common atoms between these two rings. So we can say these are the bicyclo compounds. And it has been seen that when we have this kind of rings, let's say M and N is equals to 4 और MNN is equals to 3. अगर तुम MNN को count करोगे total, ये 8 carbon हो गए total. These are 8 carbon atoms, and including these two, there will be 9-membered ring. Sorry, 10-membered ring. If I'll see M and N are 3, तो ये दोनों मिला के हो गए 6 and these two मिला के हो गया 8. So this is 8-membered ring. Again, this is 4 and 3. So this is 7 and these two ये मिला के हो गया 9-membered ring. So in short, these are medium size ring. The first is presenting your decane, second is presenting your octane, and third is presenting your nonane. So this kind of structures will bring about the changes. This kind of the medium size ring, since across the ring the functional groups are present which can interact with each other, so they tend to form the bicyclo compounds. There's something that I'm saying in the medium size ring, when across the ring there are functional group present and these sub-functional groups are capable of interacting with each other, then they shows changes in their spectral properties, as well as they tend to form this kind of bicyclo compounds rather than giving you simple salt formation. So this happens when you have the medium size ring. Now, if you'll count here, if you can see the A example again, I've written here M is equal to 5 and N is equal to 4. So ये total हो गया 9 और ये दो carbon मिला के हो गया 11. So this is your large size ring. Again, I'm counting this. This is 5 and 3, that is 8-membered, and ये दो मिला के हो गया तुम्हारा 10-membered. Now 10-membered यहाँ पे भी है और 10-membered यहाँ पे भी है. But look at the difference. On this side there is a 5-membered ring and this side there is a 3-membered, where in this case there are equal 4 and 4 on both sides. So what happens when you have 4 and 4 carbon? The distance between these two will be reduced. While in the case of 5 and 3, the distance will be comparatively large. as a result of which they cannot form the bicyclo compound, they can simply form the salt formation. Okay, so it is generally expected for the large size ring only the salt formation will take place, while the medium size ring will tend to undergo the formation of bicyclo compound. One more example I will mention here. Other examples are there. I have mentioned in my notes. I will just now focus on this. Other examples are again completely based on those carbonyl groups only. How we can just determine the other spectral property, like you can determine the isotopic oxygen in the NMR. So that kind of properties I have discussed, that you can go through it. I will discuss this compound only. These are your paracyclophanes. And if you know that the paracyclophanes in the compound, these two benzene group, they show a very strong interaction in the UV spectra. Okay, now whatever this interaction is present, generally it is expected carbonyl का एक frequency, sorry, benzene ring का एक frequency होगा UV spectra में. But over here, since these two benzene rings are present across the ring, so when they are present across the ring, they are involved in transannular interaction. And because of this, the regular UV spectra will be affected. Okay, so whichever the regular spectra you're going to get in UV spectra for these two benzene ring, that will be affected because this time these two benzene rings are present in medium size ring and they are involved in transannular interaction. Okay, everyone understood the spectral property? In short, one line about the spectral property is that because of the transannular interaction, the groups across the ring, they have interaction, they bring about some changes, and that some changes is going to cause some difference in the spectral property. So we are talking about how the spectral properties of medium sized rings are different compared to the large rings. अगर यही पैरासाइक्लोफेन्स अगर तुम्हारा लार्ज रिंग में है, सपोज M और N 5 और 5 है, तो ये तुम्हारा मोर देन 10 कार्बन एटम्स हो गया. So if it is 5 and 5, definitely this is large ring. And when you have a large ring, there is no transannular interaction because they will go away from each other. तो large ring का spectral property जो है वो अलग होगा compared to the medium size ring that we are saying.